Thank you for joining us today during reInvent 2020, where we'll talk about how you can optimize your data migration workflows using AWS Snowcone and AWS Snowball Edge. My name is Ramesh Kumar, and I'm the Senior Manager of Product Management from the AWS Snow family service, which includes a family of secure and rugged devices that you can use for edge computing and data migration. I'll provide you with an overview of the AWS services, solutions, and tools for offline and online data migration from any edge location. I'll discuss how you can use the Snow family of devices to meet your needs for data migration workflows. I'll walk you through how customers are using AWS Snowcone and AWS Snowball Edge to implement specific data migration workflows, including large multi-petabyte data migrations using multiple Snowball Edge devices. I'll provide you with some examples of customers who have used multiple Snowball Edge devices to migrate over a petabyte of data to AWS. I'll discuss how customers can use AWS Snowcone and AWS Snowball Edge to capture, process, and move data from rugged, remote, and austere edge locations where there is no network connectivity. I have a lot to cover, so let me jump in. You need to select the right service or solution or tool to migrate your data to AWS or to the cloud, depending on the amount of data that needs to be transferred and the nature of the edge location from where the data is being migrated to AWS. AWS provides more options for online and offline data migration from on-premises edge locations and rugged, austere, and remote edge locations than any other cloud provider. I'll provide you with an overview of the AWS services, solutions, and tools that you can use for offline and online data migration from any edge location. For data migrations from on-premises edge locations, you have AWS Storage Gateway that is shown on the top left. AWS Storage Gateway supports three types of gateways: Volume Gateway, File Gateway, and Tape Gateway, which enable customers to have a seamless connection between their on-premises locations and the AWS storage services, caching data locally for low latency access. Below Storage Gateway, you see AWS Direct Connect. With AWS Direct Connect, customers can establish a private network connection between AWS and their data center or office to reduce costs, increase bandwidth, and for a more consistent network experience. You can see the options that are available from AWS for online data transfer of files and objects at the top. With AWS Data Sync, customers can quickly and easily move large amounts of data from the edge to AWS storage services, including Amazon S3, Amazon EFS, and Amazon FSx for Windows File Server. With AWS Snowcone, it comes pre-installed with AWS Data Sync, which means customers can use Snowcone as an small online data transfer appliance to transfer up to 8 terabytes of data to AWS. This type of online data transfer solution or appliance is ideal for the use by small and medium businesses. Think about doctors' offices or accountants' offices. It can be used by prosumers like photographers or freelance journalists, or even by consumers. Such type of customers can use Snowcone to transfer machine data, customer information, photos, images, and videos, either from their office or from their home, by simply copying the data onto Snowcone first, connecting Snowcone to the network, and then using AWS Data Sync to transfer the data to AWS. You see the AWS transfer family, which enables you to directly transfer files in and out of Amazon S3. The transfer family supports FTP, secure FTP, and FTP over SSL. And then you have the Amazon S3 transfer acceleration, which speeds up content transfers in and out of Amazon S3 by up to 50 to 500%, especially for long-distance transfers of large objects. For offline data transfer from on-premises edge locations and the rugged non-data center edge locations, customers can use the AWS Snow family. Customers can use AWS Snowcone, AWS Snowball Edge, or AWS Snowmobile to complete their offline data migration. In the next section, I'll talk about how you can use the Snow family of devices to meet your needs for data migration workflows. I'll provide you with an overview of the AWS Snow family. On the right, you see AWS Snowball Edge and AWS Snowcone for edge computing applications. Customers can use the Snow family of devices as an IoT hub to capture and collect sensor data, process the sensor data locally in real time. Customers can implement image processing or video analytics functions on the Snow devices at the edge, and customers can also run machine learning inference models on the captured data at the edge location. In these operations, the Snow devices can operate or function independent of any network connectivity and independent of AWS for long periods of time, which makes the Snow devices suitable for use in disconnected environments or in environments where there is no consistent network connectivity or maybe a network connectivity with low bandwidth. On the left, you see AWS Snowcone, AWS Snowball Edge, and AWS Snowmobile for data transfer applications. Customers can use multiple Snowball Edge devices to migrate up to 10 petabytes of data to AWS. And they can use AWS Snowmobile for large data center migrations. Customers can use AWS Snowcone and AWS Snowball Edge to capture, process, and move data from the rugged, remote, and austere edge locations where there is no network connectivity. When data is copied onto Snowcone or Snowball Edge, it is automatically encrypted using 256-bit encryption keys that you can manage using AWS Key Management Service or KMS. The encryption keys themselves are never stored on the Snow devices, which means that your data is safe and secure during device transit. Snowcone and Snowball Edge feature a Trusted Platform Module or TPM, which provides a hardware root of trust. Customers can select AWS Snowcone or AWS Snowball Edge or AWS Snowmobile to implement their offline data migration workflows from either on-premises edge locations or a rugged, remote, and austere edge location. You can learn more about the Snow family of devices from the Snow family web pages that is available at the link shown at the bottom. Snowcone is ideal for data migrations up to 24 terabytes of data using up to 3 devices. Customers can use multiple Snowball Edge devices to migrate up to 10 petabytes of data to AWS. Both Snowcone and Snowball Edge are rugged devices, which means they can operate in harsh conditions. They can withstand vibration. They can operate in humid and dusty environments. You can operate Snowcone and Snowball Edge in outdoor locations in the rain, in cold temperatures, or hot climates. Snowcone has 8 terabytes of storage capacity, while Snowball Edge has 80 terabytes of storage capacity. Once you copy data to Snowcone, you can transfer the data by shipping the Snowcone device back to AWS for offline data transfer, or for ongoing use cases, simply connect Snowcone to the network and transfer the data online using AWS Data Sync. You can run your filtering, pre-processing, or data transfer applications on Snowcone and Snowball Edge. Snowcone supports 2 CPUs and 4 GB of RAM memory for the compute applications, while Snowball Edge supports up to 40 vCPU and 80 gigabytes of RAM memory to support your compute applications. You can develop your compute applications in the AWS Cloud. You can develop your applications as Amazon EC2 armies in EC2 in the AWS Cloud. Once you've tested and validated your applications, you can deploy your Amazon EC2 armies on the Snow devices on the Amazon EC2 instances that are hosted on the Snow devices. You can also run AWS IoT Greengrass functions on Snowcone and Snowball Edge. Snowcone is lightweight. Customers can carry it in a messenger's bag or a backpack. And for these mobile portable workflows, Snowcone can operate with a battery. Customers can use up to 15 Snowball Edge devices to create a storage cluster and store over 1 petabyte of data at their edge locations. Customers can use AWS Snowmobile for large data center migrations. AWS OpsHub is an easy-to-use, intuitive graphical user interface tool that customers can use to manage multiple Snowcone and Snowball Edge devices at their edge location. To use AWS OpsHub is pretty easy. Simply download AWS OpsHub onto a local machine, such as a laptop that is connected to the same local network as Snowcone or Snowball Edge. You can use AWS OpsHub to set up, configure, and unlock your Snow device with just a few clicks. Then you can use the OpsHub dashboard to monitor the resources available on the Snow device, such as the number of available CPUs, the amount of gigabyte RAM memory, and the available storage. For running your edge computing or other applications on the Snow devices, you can use AWS OpsHub to create an instance of the Amazon EC2 armies that have already been loaded onto Snowcone or Snowball Edge. And from there, you just simply run your edge computing application. For data transfer applications, you use AWS OpsHub to set up your NFS file transfer or your Amazon S3 compatible object transfer onto the Snow device. Once that is set up, you simply drag and drop files and objects onto the Snow devices. With Snowcone, once you've completed copying data onto the device, if you want to transfer the data online using AWS Data Sync, then you can use AWS OpsHub to activate the data sync service on the Snowcone device, and then simply set up the online data transfer task between Snowcone and AWS. In this section, I'll walk you through how customers are using AWS Snowcone and AWS Snowball Edge to implement specific data migration workflows. First, I'll walk you through some of the challenges that customers face when they're migrating data to AWS. In some edge locations, customers may not have a consistent network connectivity that they require for any online data migration to AWS. In some other edge locations, customers may have a consistent high bandwidth network connection, but they may need that network bandwidth for their day-to-day production or operational use, and they may not be able to dedicate that network bandwidth for the data migration. The table shows the amount of time it takes for customers to migrate data to AWS, depending on the amount of data that is being migrated and the amount of network bandwidth that is available and that can be dedicated for the data migration. You can see that if you want to migrate 1 petabyte of data to AWS, it'll take you a long amount of time and a large amount of time unless you can dedicate at least 10 gigabits per second of network bandwidth for the data migration. Some of the other challenges that customers face for data migration include restrictions of protocols, incompatible file systems, use of mainframes for the data migration at their edge location, or they have databases running on legacy equipment. In some use cases, customers may be capturing sensor data or other machine-generated data or videos or photos in remote, rugged, austere edge locations where there may be no network connectivity for the online data transfer. To use a Snowcone device or a Snowball Edge device, customers can place an order for the Snow device on the AWS Management Console. During the job order, customers select the type of Snow device that they want to use for their data migration workflow. They set up the S3 buckets to which the data needs to be migrated. They can also load Amazon EC2 armies onto the Snow device if they want to run any filtering, pre-processing, or data transfer applications as part of their data migration workflow. Once the job order has been placed, AWS will prepare the Snow device based on the configurations and options selected during job order. And then we'll ship the Snow device directly to your edge location. We can ship it directly to an on-premises location, or we can ship the device to the rugged edge location from where the data is being generated and needs to be captured. Once customers receive the Snow device at their edge location, they can use AWS OpsHub to set up, configure, and unlock the Snow device. You can set up any edge computing application or any data transfer application that you want to run on the captured data prior to migration to AWS. You can use OpsHub to set up the NFS file transfer or the data copy using the Amazon S3 endpoint on the Snow device. Once you've copied data onto the Snow device, then the address label on the e-ink display of the Snow device flips to point to AWS. You simply ship the Snow device back to AWS, and we'll ingest or import the data from the Snow device to the S3 buckets that were set up during the job order. The job is now completed, and we will securely erase any data, any options or configurations on the Snow device following NIST guidelines. Prior to completing any large multi-petabyte data migrations using multiple AWS Snowball Edge devices, we recommend that you implement a proof of concept with 1 or 2 Snowball Edge devices. The proof of concept will help you address any shortcomings or gaps in your local network for the data copy to Snowball Edge. Maybe it's the amount of network bandwidth or the type of computers and servers required to make the data migration to Snowball Edge. The proof of concept will help you implement best practices, such as batching of small files to make it easier, faster, and more efficient to copy data onto the Snowball Edge devices. You can also assess or understand the ability of your local network to simultaneously copy data onto multiple Snowball Edge devices. Once your proof of concept is completed, you can work with the AWS account team or solution architects or directly with the AWS Snow family service to plan and orchestrate your data migration. For example, if a customer wants to migrate 2 petabytes of data using 25 Snowball Edge devices, and their local network can simultaneously copy data onto 5 Snowball Edge devices, then we will set up and plan a data migration using 5 rounds of 5 devices in each round. We'll ship you 5 Snowball Edge devices, and when the data is copied onto the 5 Snowball Edge devices, the next set of 5 Snowball Edge devices will be available to you at your edge location for the next set of data copy. You can learn more about large multi-petabyte data migrations using multiple Snowball Edge devices from the white paper that is available at the link shown at the bottom. I'll provide you with a couple of examples of customers who've used multiple Snowball Edge devices to complete large data migrations. Photobox is an online photo products company which serves millions of customers in Europe. Photobox wanted to get out of the business of owning and maintaining their own data centers, and they wanted to redeploy their resources into artificial intelligence so that they could provide an improved customer and user experience. Photobox had 5.7 billion photographs, which amounted to 10 petabytes of data that were stored in storage devices and storage arrays in 2 different locations. Photobox used multiple Snowball Edge devices to migrate the 10 petabytes of data from their 2 data centers or locations to Amazon S3. Once the 10 petabyte data migration was completed to Amazon S3, Photobox realized reduced costs, but they also realized the benefits of improved performance by Amazon S3 and improved durability of Amazon S3 compared to what they could support in their own data centers. You can see the quote from Photobox at the bottom of the slide. Latte is an e-commerce shopping site that serves 39 million customers across 7 different storefronts. Latte had 140 million files, which consisted of product images and other media assets that they wanted to transfer and transform to provide a better user experience. Latte decided to use multiple Snowball Edge devices to migrate the 140 million files to AWS. In order to complete their data migration, Latte did not have to add any new expensive networking or IT equipment. Latte was able to use multiple Snowball Edge devices to safely and securely migrate the 140 million files to AWS, and they were able to complete the data migration within just 2 weeks. Once the data was in AWS, Latte was able to use over 70 AWS services to transform their media assets and product images in order to provide a better customer experience. You can learn more about Latte's use case and experience at the Snow family web pages. You can see the quote from Latte at the bottom of the slide. Now let's talk about how customers can use AWS Snowcone and AWS Snowball Edge to capture, collect, process, and move data from remote and austere edge locations where there could be no internet connectivity. Snowcone is a small, ultra-portable, rugged, secure edge computing and data transfer device. Snowcone is lightweight. It just weighs 4.5 pounds or 2.1 kilos, which means customers can carry Snowcone in their backpack or in their messenger bag. Snowcone is rugged. It can withstand vibration, can operate in outdoor locations. It can operate in the rain, in freezing cold conditions, and hot desert-like climates. Snowcone offers 8 terabytes of storage capacity, and you can run edge compute applications on Snowcone on the 2 CPUs and 4 gigabyte of RAM that's available for use. Once you've copied data onto Snowcone, you can ship the Snowcone device back to AWS for offline data transfers. For ongoing use cases where a new set of data is being generated in the field on an ongoing basis, think about data generated by machines on a factory floor or sensors in the field or a new set of images or videos captured by a drone, you can keep and use Snowcone for the long term. Once you've copied data onto Snowcone, simply connect Snowcone to the network, either at your home or your office or even a hotel room, and transfer the data online to AWS using AWS DataSync. This approach allows you to use Snowcone for the long term, for ongoing use cases, and you can continue to use Snowcone to capture data in an autonomous vehicle. You can attach it to a moving robot that is collecting data from sensors in a large field, or you can attach Snowcone directly to the drone to capture images or videos from the drone's camera. Let's talk a little bit more about those ongoing workflows using AWS Snowcone and AWS DataSync. The architecture that you can see has AWS on the right, which includes the AWS storage services. You can see Amazon S3, Amazon EFS, and Amazon FSx for Windows File Server. DataSync service and the control plane of the DataSync service runs in the AWS Cloud. And on the left, you see the rugged or outdoor edge location. Given its small form factor and ability to operate in harsh conditions, you can deploy Snowcone right next to the machines or sensors that are generating new data. You can copy data onto Snowcone, and once you've copied data onto Snowcone, you can use AWS OpsHub to activate the DataSync service in order to complete your migration. All Snowcone devices come pre-installed with the DataSync agent. The DataSync agent is installed as an AMI running on the Amazon EC2 instances that are hosted on the Snowcone device. So once you've copied your data onto Snowcone in the rugged edge location, you can carry Snowcone to a place where there's network connectivity. Again, your home, your office, or a hotel room connected to the network, and transfer the data to AWS. Now the Snowcone device is available to you to capture and process the next set of data generated at the rugged edge location. In this picture, customers are using Snowcone in the field to capture data from sensors and other machines, and the data can be processed in real time at the edge location. In the upper right, you see Snowcone being used in a construction site. For these space-constrained and power-constrained environments, you can operate Snowcone with a battery. In this picture, customers are using Snowcone on a ship for oceanographic exploration or oil exploration. The data captured by the many sensors at the ship or below the ship can be stored onto the Snowcone device. You can run some lightweight analytics application on the data that is captured on Snowcone so that you just store the useful data. Once the ship comes back to port, you connect Snowcone to the network and transfer the data from Snowcone to AWS. Now the Snowcone device is available to you to capture the next set of data on the next voyage of the ship. In this picture, customers are using Snowcone in a retail establishment where maybe there is no consistent network connectivity, or there's a network connectivity, but there is the network bandwidth is very low. Customers can use Snowcone in this type of use cases to store point of sale data, or capture images or videos and analyze data at the edge location. Thank you for joining us today and during today's session on optimizing your data migration workflows using AWS Snowcone and AWS Snowball Edge. Please complete the session survey.